Just a little summary information about COVID-19. By now, we have all heard about it and are very aware of the impacts it has on everyday life. So COVID-19 is caused by a type of coronavirus, which is part of a large family of viruses. Its emergence is believed to have begun in Wuhan, China in December of 2019. The origins have been widely speculated, but it is believed to have been present in animals and recently changed hosts. As of May 4th, the CDC says there are more than 3 million confirmed cases globally, with more than 1 million of those cases in the United States. On a sadder note, of those cases, over 239,000 people have died, with 67,000 of those cases coming from the United States. This virus has captured attention on a global scale. With this wide range, this has increased the information circulating to the public. I decided to compile text from websites, articles, and other alerts to create a word cloud to determine what are the main topics circulating the media. Surprisingly, the most common words are contact, people, and the South coming in as a close third. This makes some sense since more recently, the coronavirus news has focused on how it is spread and how to avoid it. As far as the South, I think this is because after only a couple of weeks of the stay-at-home order, the South is opening up again, even though everything never truly closed down. I know this because I have family in Mississippi and Alabama, and they have said that their routine was barely changed due to this virus. A lot of eyes are on this area because they have done little to try and flatten their curve, and the results could be devastating.
One of the data sources we used was the Google data on mobility changes relative to the period of time from January 3rd to February 6th. I will focus on the workplaces for this presentation. In this plot, you can see the averages of states' relative mobility across the United States. The red line is the date of the National Declaration of a State of Emergency, which was on March 13th. It appears to correspond with the relative mobility beginning to drop, but we wanted to look more closely at the state-level data. Here we have the relative mobility for Washington, the state with the earliest declaration of a state of emergency, and West Virginia, the state with the latest. The date of the state declaration of a state of emergency is the solid red line, while the national one is the dashed red line. The date of the stay-at-home order is the purple line. Here we have California, the state with the earliest stay-at-home order, and South Carolina, the state with the latest of those that had stay-at-home orders. It appears from these four examples that the stay-at-home orders and state of emergency declarations had an effect on the relative mobility in these states, so I wanted to test whether there was a relationship across all of the states that we have data for. To do this, I used a simple linear regression. The relationship between the declarations and the relative mobility is probably a lot more complex than this, but I wanted to establish whether a relationship existed. I used a threshold of negative 38% relative mobility because that was where the slope of the line of states' averages began to level out. The dates used in the regressions are relative to the National Declaration of a State of Emergency, so March 13th is 0. I found that the date when states reached a threshold of negative 38% relative change in mobility was positively correlated with both the dates of the state declaration of a state of emergency and the stay-at-home order. Meaning the later states responded with these measures, the later people reached this threshold of staying home from workplaces. If I had more time to analyze this, I would have liked to look more at the relationship between the slope of the change in mobility and these orders and declarations. I am also interested in whether the number of cases in states affected people's perception of the severity of the situation and made them more likely to stay home from work.
One thing I was interested in was seeing whether or not this decrease in social mobility accurately reflected the spread of COVID throughout the United States. To determine this, I created a simple animated plot demonstrating last reported COVID cases at the county level by associating the New York Times cases and deaths data with the relevant county geometries. Clearly, we see an explosion of diagnosed cases in the early to mid-March period, right around when social mobility fell. Furthermore, I attempted to examine some metric of the number of deaths with respect to the number of cases to see if I could relate that to publicly available insurance and socioeconomic metrics found through the census. But ultimately, I found that this ratio is dominated more by population density than anything else. For this reason, those figures having to do with insurance rates and wealth are omitted.
Associations between the virus's contagion and mobility. To do this, we looked at daily state level data. To look at mobility trends, we used Google's COVID-19 community mobility reports, which essentially is a daily aggregation of users that agree to have their smartphone location data aggregated. Google has 6 different categories of locations that they mark based on usage of those locations, such as grocery, workplaces, transit stations, residential areas, and so forth. We combined this with an estimate of the estimated reproductive number, which is a Bayesian inference-derived time-varying estimate of the reproductive number that you might be familiar with from a more simple SIR model. And just as a reference point, if r sub t is less than 0, then that means at that point of time, one would estimate that the population is experiencing viral spread below the contagion threshold, so that any existing outbreak would decline back to 0. In terms of results, we measured both correlation, Pearson's R, and rank correlation, Spearman's rho, and we found results that perhaps aren't too surprising. We found positive associations between activity at social locations and increased spreading of the virus. And we also found negative associations between viral transmission and increased presence at residential locations.